our discussion about slope, I would like to notice a few things about slope. We saw two particular cases of slopes. We saw a positive slope and we saw a negative slope. When we had a slope that was bigger than 0, what did we see? We saw a line that went upward. I would describe this as going upward because it's going up as we go to the right. Whereas when we had a slope that was less than 0, we had a line that went down. So if we have a negative slope, it is going down. So that's an important thing to notice about slope, is that its sign, whether it's bigger than 0 or less than 0, means that it's going up or down. There are also two special cases which I didn't cover, but let's pretend that I have a horizontal line that's supposed to be horizontal. Let's pretend it is. If I have a horizontal line and I'm looking at the rise over the run, well, the y-coordinate isn't changing. The y-coordinate is staying the same, so the rise has to be 0. No matter where I move along the line, there is no change in y. Whereas the run, well, the run can be whatever I want it to be. It could be some number. I could start here and go to here. Whatever that number is, the whole point is that when I do the slope of a horizontal line, I get 0. So m is equal to 0 when I have a horizontal line. How about a vertical line? Well, here's a vertical line, and let's think about what its rise over run is. Well, if I take two different points here, the rise is going to be some number. I can start down here and move up here. I've actually moved some actual distance. But my run, x doesn't change. I'm not moving left or right. I'm just going straight up and down. So my run is necessarily 0. I can't divide by 0. So what we have is that the slope for a vertical line is, we'll say it's undefined, because dividing by 0 is undefined. It simply does not make sense. So these are the four cases of slope. If it's positive, it's an upward sloping line. If it's negative, it's a downward sloping line. If the slope is 0, it's horizontal, and if it's undefined, it goes up and down. Now, we talked about the standard form of a line, but there are two other forms that are really more familiar to us, maybe, and are really going to be more useful, well, are more useful in certain contexts, especially in terms of graphing. So the first of these is going to be the slope, that says slope-intercept form. And this looks like this. Y is equal to mx plus b, and here m is equal to the slope, and b is equal to the y-intercept. Okay. I'm just going to take it for granted that this is what it is, but if you'd like to see why this works out, you can check it out in the book. But this is the slope-intercept form. We can get, if we know the slope and the y-intercept of a line, we can immediately get an equation for it. So why don't we do an example? We're going to find I'm going to give you a line, we'll find the slope and the y-intercept, and then we'll find the equation. So let's suppose I have this line here, and let's suppose that it goes like up to here, and so that means it'll go like up to here, and it'll go down to, I suppose, here, and then down to here, etc. So that's my line. Okay, let's find the slope-intercept equation, and I'll often abbreviate equation EQN. Well, to do this, we're going to want to find the slope and the intercept of this line. We're looking for the y-intercept, so we're looking for where the line hits the y-axis. So we don't want the x-intercept, we want the y-intercept right here. Where does it hit the y-axis? 0, 1, 2, 3. It hits at 3. So this tells us that b is equal to 3. How can I find the slope? Well, let's find another point on the line, okay? This looks like another point on the line right here. If I just draw a line for you, you can assume that it goes through any points that it looks like it goes through. This one looks like it goes through the point 1, 5, so let's just assume that it does, 1, 5. And we can use the explicit formula then for slope to figure out what the slope is. Now the y-intercept actually corresponds to the point 0, 3 because x is 0 and y is 3. So that means that our slope will be y2 minus y1, 5 minus 3, divided by x2 minus x1, which is 1 minus 0. It's 1 minus 0. It's 2 divided by 1. Anything divided by 1 is itself. So that's the slope, and the equation for this line is y is equal to 2x plus 3 because it's mx plus b. Fantastic. We started with the line, we found the slope and the intercept, and we got an equation for it. Okay, let's do an example. Let's say goodbye to the coordinate plane. Let's do an example where we start with something in standard form and we find out what the slope and intercept are by getting it into slope-intercept form. So let's suppose I have something like, I don't know, 2x plus 5y is equal to 10. If I want to put this into slope-intercept form, what I need to do is solve for y. Because slope-intercept form has y all by itself. So I've got 2x plus 5y is equal to 10. And the first thing I can do is bring x onto the other side by subtracting 2x from both sides, because I want y all by himself, or maybe y is female, herself. So I got 5y is equal to negative 2x plus 10. Now I've got 5y. I need to get rid of the 5. It's 5 times y, so I'll divide both sides by 5. When I divide by 5, I really have to divide every single term on the right by 5. I have to divide negative 2x by 5 and 10 by 5. So what this leaves me with is y, because 5 cancel out here, is equal to negative 2/5 x, because negative 2 over 5x, plus 10 divided by 5 is 2. So then what is the slope? The slope is just whatever is in front of x, negative 2/5. And what is the y-intercept? It is whatever constant we have over here, which is 2. Great. And from here we can actually go ahead and graph this equation. Let's go ahead and graph that equation. So what we had was y is equal to negative 2/5 x plus 2. Well, this is the y-intercept, so that means that's where we hit the y-axis, at 2. Now, this is our slope, and we can interpret this as if x goes up by the denominator 5, if we go up by the run, then y changes by the rise, which is 2. But since it's negative, y is going to go down. Y goes down 2. So here I am, and I go over 1, 2, 3, 4, 5, and then I go down 1, 2, and I hit right here. And I can keep going along like that to get a graph of this line. And I can, if I go backwards, if I go 1, 2, 3, 4, 5 to the left, x is going down by 5, y will go up by 2. So I go up to here, and then up to here, and it just keeps going. There is a graph of my line. I didn't even have to plot any specific points because I just used, well, I plotted one point, which was the y-intercept, but then I used the slope to figure out other points along here. Fantastic. Now there's one final form that is really important to us, and it's something that you may or may not have seen before. And this is called the point slope form. Okay. Now it looks like it says paint slope form, but believe you me, that's supposed to say point slope. There we go, point slope. Okay, what is the point slope form? Well, if we have a line that has slope m, and if it goes through the point, let's say x1, y1, then it has the equation y minus y1 is equal to m times x minus x1. This is a more general formula than point slope, slope-intercept, because we don't need specifically the intercept. We can just use this specific point. Again, you can refer to the book or talk to me to see why this makes sense. Let's just note, though, that y and x are variables, whereas y1, x1, and m are all constants. They're constants. Okay, so let's plug this in. Let's see how this works. So, for example, let's find the equation of the line. Let's find the equation when we are looking at the slope equal to -4, and let's say the point that it goes through is 2, -5. Okay. So the equation of this line then is going to be y minus y1, which is -5, is equal to -4, which is the slope, times x minus 2. And the only simplification we really need to do here is to take minus -5 and turn that into +5. So we get y plus 5 is equal to -4x minus 2. That's good enough. This is an equation for the line. You could go ahead further and solve for y to get the slope-intercept form, but I'm going to avoid that for the time being. It's important, but not the most important thing. I want to do one more example of this sort of thing. So let's find the equation for the line that goes through, let's say 1, 2 and 3, 4. Well, I've only given us 2 points here. I haven't actually given us a slope. But we can find the slope if we know 2 points. Okay, so our 2 points were 1, 2 and 3, 4, and we know that the slope is then y2 minus y1, 4 minus 2, divided by x2 minus x1, which is 3 minus 1. 4 minus 2 is 2, 3 minus 1 is 2, 2 divided by 2 is 1, so m is equal to 1. Now, this means that we can apply the point slope form. And it doesn't matter which point we use. We could take y minus this guy, so y minus 2 is equal to 1 times x minus 1. And that's just y minus 2 is equal to x minus 1. Or we could take, say, y minus 4 is equal to 1 times x minus 3. Which leaves us with y minus 4 is equal to x minus 3. Let me just note that if you add 1 over here, or if you add 2 over here or add 4 over here, you end up with the equation y is equal to x plus 1. So we in fact get the same exact guy in either case. Fantastic.